Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about solving equations involving absolute value. If this is your first time to my channel, thanks so much for coming. I hope you come back, and please consider subscribing. I'd love your support. How do you solve equations involving absolute value? They seem a little difficult, right? But the good thing is they're really not. So if you have an absolute value in your equation, then you can isolate the equation for the absolute value, the term that has the absolute value, and then you can use this rule that I'm going to discuss right now. So if C is any positive real number, and U is any algebraic expression, and it will probably involve a variable like x, then we can use the following rule to solve the equation. The absolute value of U equals C, and again, U is some expression. U could be 5x plus 2, or U could be something else. But U just represents some algebraic expression, and C is just a positive constant. So the absolute value of U equals C means U equals either positive C or U equals negative C. So we can get rid of the absolute value and create two options, two cases, and we just solve those two cases and we get our answer. And any real number x that makes the equation true is a solution. Let's do an example. We have example A here, says absolute value of quantity 2x minus 3. So this right here, the 2x minus 3, is our U, and our C is 11. So we have the absolute value of U equals C in this case. U is the algebraic expression 2x minus 3, and C is 11, a positive constant. All right, so let's solve this equation. Here we have we have our absolute value. We can get rid of it by creating two scenarios, right? So our option 1 is 2x minus 3 equals the positive 11. And the option 2 is 2x minus 3 equals negative 11. We solve these two and get our answers, and we should be good. Let's go back to the first one. 2x minus 3 equals 11. We add 3 to both sides. That gives us 2x equals 14. We can divide by 2 on both sides, and we get x equals 7. We can plug that back into the original equation and see that we get a true statement, so that is a valid answer. And let's go to the option 2 and solve this second equation. Again, we add 3 to both sides. We get 2x equals negative 8. We divide by 2, and we get x equals negative 4. We can plug that back into our original statement, the original equation, and see that we get a true statement as well. So x equals negative 4 is also a valid solution. Not as bad as it looks, right? Let's do another one. Our second equation here is 4 times, and I put the absolute value in orange, so you can tell the difference between an absolute value and a 1, for example. So I have 4 times absolute value of 1 minus 2x, minus 20 outside the absolute value equals 0. So let's isolate the term with the absolute value. So I'm going to add 20 to both sides. That gives me 4. I need my absolute values in orange. Inside we have 1 minus 2x, and now we just have equals positive 20. We can divide both sides by 4, and we get absolute value of 1 minus 2x equals 20 divided by 4, which is 5. Now again, we have our two options. Option 1 gives us 1 minus 2x equals positive 5. 1 is pretty terrible. And our option number 2 gives us 1 minus 2x equals negative 5. And we solve these two options, and we will have our answer. Let's do the first one. So we subtract 1 on both sides to get the x by itself. We're just trying to solve for x. That gives us negative 2x equals positive 4. We can divide by negative 2. And that gives us x equals negative 2. We can plug that back into the original equation and verify that we get 0 equals 0. So that's a true statement. So that's also a valid solution. And let's do our second option here. 1 minus 2x equals negative 5. Again, we will solve for x. Subtract 1 on both sides. Minus 2x equals negative 6. Divide both sides by negative 2. That gives us x equals 3. We can plug that back into the original statement and the original equation and verify that it gives us a true statement. I'll leave that for you to do if you like. That is also a valid solution. X equals 3, so we have two solutions. X equals negative 2 and x equals 3. Not too bad, huh? Let's do another one. How about this? This one, we have the absolute value of quantity x plus 1. And then outside that, we have plus 5 equals 3. So again, let's put it in the correct form. And we have absolute value. Well, I guess I need to subtract 5 on both sides first, right? Then we have absolute value of x plus 1 equals 3 minus 5 is negative 2. At this point, we stop because we think, is this even possible? Why do we say that this constant, remember our rule said the absolute value of u has to equal c, and c had to be a positive constant, a positive real number. Why does c have to be positive? Because nothing can come out of the absolute value and be negative. That's the rule of the absolute value, right? It makes any negative positive, and it keeps any positive positive. So anything that comes out of an absolute value has got to be positive. So it is literally not possible to have some number, x, and then add 1 to it, take the absolute value, which makes it positive, and have the result be negative 2. It's impossible. Absolutely impossible. Just to show you, let's keep going. Let's say, well, this was actually valid, and we just keep going, right? Let's try. So this would give us two options. This would give us x, option number 1, x plus 1 equals negative 2, and then option number 2, x plus 1 equals the opposite, the negative of that, so it would be positive. Let's solve for x. This one gives us, we take the x to the other side, we get negative 3. This one, we take the negative 1 to the other, subtract 1 from both sides, and we get x equals positive 1. Let's plug both of these back in to the original statement to see if this is actually valid. We have the absolute value, x plus 1 plus 5 equals 3. So negative 3. So absolute value of negative 3 plus 1 plus 5, does that equal 3? Negative 3 plus 1, that's 2. Negative 2 absolute value plus 5, 3. Absolute value of negative 2 is 2. 2 plus 5, does that equal 3? Nope. 7 equals 3. That's not a true statement, you see. We can see this is not, we verified that this is not valid, right? 7 doesn't equal 3. It's impossible. We could check the other one and we'd get the same thing, right? X plus 1, meaning we would get a statement that was not true, which told us that the number we came up with as our solution is invalid. Plus 5 equals 3. If we plug in 1 here, we get 1 plus 1 plus 5 equals 3. 1 plus 1 is 2. The absolute value of 2 is 2. Does 2 plus 5 equals 3? Nope. That's 7 equals 3. Not true. Neither of these statements are true. So the two answers we came up with aren't valid. But we knew that, right? Because we knew at the beginning, we knew that we could not have something that was coming out of an absolute value, meaning it was positive. It couldn't be negative. So we knew that this was there's no solution here. So our solution is the empty set. That's the 0 with that slash through it. No solution for this equation involving an absolute value. Let's do one more. This is our last one, and this is kind of a unique one because we have 2 absolute values. So there's a little trick here. If you have 2 quantities in absolute value, I have a note here that helps you on the right. The absolute value of A equals the absolute value of B if A equals B or if A equals negative B. So we use that rule and we can easily solve this problem. So we have 2 options. Our option 1 is either 3x minus 1 equals x plus 5, or option 2, we have 3x minus 1 equals the negative of x plus 5. We solve these 2 equations and we have our answers. Let's get all the x's. Let's do option 1. And that n in option 1 is pretty horrific. The new one isn't much better, but it looks a little bit better. Anyway, let's solve this equation. Let's get all the x's to the left and all the numbers to the right. So let's take the x to the left. So we subtract x on both sides. That gives us 2x minus 1 equals 5. Let's add 1 to both sides to get the 1 on the right. That gives us 2x equals 6. We can now divide by 2. And we get x equals 3. We can plug that back into the original statement and see that we get a true statement back. But I'll let you do that. That's a valid statement. Let's do option number 2. Let's distribute the negative through. That gives us 3x minus 1 equals negative x minus 5. Now we solve for x. So let's add x to both sides. That gives us 4x minus 1 equals negative 5. Let's add 1 both sides. We get 4x equals negative 4. And we divide by 4. Leaves us with x equals negative 1. That one is also a valid solution. You could check it by putting it back into the original equation and verifying you get a true statement out. But that's it. That's how you solve equations in algebra using or involving absolute values. Hopefully it was helpful and hope you guys have a great day.